So you have big data. Now what? My name is Naomi Freeman, and I'm here because I want to share what I've learned about launching big data projects. You can find me at Naomi_Freeman on Twitter, and feel free to say hello, send cats or Christmas. You can ask questions in the chat, depending on the questions. Yeah, Sapphire's saying we have a 5-minute Q&A at the end. If you have a really pressing question, we might grab it in between. We'll just feel that out. So, since the dawn of time, humans have had questions and have been seeking answers. Should I marry him? Should we take our boat? Should I take that job? We can't seem to help it. We have questions and we want some certainty with our answers. We want to know that we're doing the right thing, the best thing. And we have used a variety of tools from the Greek oracle to this here magic 8-ball. Of course, in business and technology, we've moved to using slightly more complex and more reliable tools like big data to find our answers. And I think this quote by Eric Schmidt really speaks to the moment that we're in. There were 5 exabytes of information created between the dawn of civilization through to 2003. That much information is now being created every 2 days. It's staggering the amount of information we really are creating, processing, and sending every day. What exactly is big data, though, compared to any other kind of data? For those already working in data science, the image here may be familiar. Just to be sure we're all on the same page with what we're talking about when we say big data, though, here's what we mean when we say big data in this talk. Typically, data is described as having 4 V's: variety, velocity, volume, and veracity. So big data isn't just about the volume, which is the first thing that usually comes to mind. It's also about how quickly that data is moving. Petabytes per second is a much different conversation than going and looking for one static file every few months. We're also talking about variety, the different kinds of data that we can have stored, both in whether it's structured or unstructured data, but also increasingly more complex data like audio, images, and video. The final V is veracity, which in the context of big data is about the truth of the data or the trustworthiness of the source that it's coming from. So with the advent of big data, we can move from the magic 8-ball and into answering much bigger questions like, what's the most efficient way to get a cargo ship from Bergen to Tromsø with the best fuel optimization possible? We can also ask questions like, is it likely, given my current circumstances and health, that my child will be born with a genetic disorder? Or we can talk about, can we predict the sales volume for this new product before it even launches? Each of these is a really great question. So we take them, we throw a bunch of data at them, and ta-da, it's magic, right? With all these buzzwords and hype flying around, though, we have to wonder, are we actually getting any better at answering our big questions with big data? According to Statista, the expected value of the big data industry is expected to be $174 billion in the next 15 months. That's a huge amount of money. So big money, big wins, right? Well, according to a compilation report on designing for analytics with data combined from Gartner, New Vantage Surveys, and VentureBeat AI, a whopping 60 to 85% of big data projects fail. Complete and utter failures by whatever measure. So what are we missing? Newer models of the 4V big data diagram recommend a 5th component, value. And I really think that this is vitally important, the key ingredient that gets left behind in a lot of the rush to launch big data projects. And value is simply what you probably think it means, the actual monetary value or the worth of the data being collected. It's just the truth that much of the data a business stores may have little or no value at all in decision-making or improving operations. You might have kept the data for, I don't know, compliance reasons, or simply because you thought you should capture as much as you could as soon as you could. If you're finding as you comb through the data that there is data with no current value, and you sincerely can't anticipate it being of value in the near future, it may be best to simply stop collecting it. Data that has no value can often serve as a big distraction and can only slow down or even confuse the data analysis process. So we've established you have big numbers. We're assuming you've now identified some value, and you're still pretty certain you have some type of big data. Now we're going to do something with it. And how are you going to do something with the big data? So before we jump into some tools and methods, let's briefly take a look at culture. See, we're not at a place yet where the data is going to process itself. Although that would be lovely, it would also put me out of a job in some instances, but hey. The first thing we need to look at is the culture of the folks that are going to be working with the data, because they're doing the work, they have to engage with this. Big data is going to require some big culture change, but we can break it down into 3 key pieces. Establishing processes around handling the data and best practice, including collection. Everyone on your team should be involved in this because it's likely everyone's collecting and storing some form of data in some way. And if you don't know what that is, check your Google Sheets and check the shortcuts on people's desktops. I'm sure you will find data collection. There also has to be a culture around scrubbing the data. So scrubbing the data is a more technical practice at some levels, but everyone in the team should be involved in keeping track of and on top of the data scrubbing to avoid disrupting other workflows in future. Key here for the whole team is really about formatting the things. So making sure date timestamps are all the same, for example, and ensuring that every time something's stored, that it's stored in the same format. It's also about handling missing values in data when they arrive and clearing out duplicates whenever they're found. Finally, there's going to have to be business rules implemented across the organization before data handling occurs. So this can be related to your specific industry like banking, healthcare, as well as to larger legal frameworks and industry best practice. The good news is that while this takes some time to implement, once companies have made the cultural change, they usually don't go back, and their operating improvements are not easily replicated by competitors. So successfully implementing the data culture then itself relies on 4 key practices. First is establishing a disputed source of performance feedback. Next, you want to consciously articulate business rules and regularly update them in response to new facts. You want to make sure that decision makers at all levels get near real-time feedback. And finally, you're going to need to be providing high-quality coaching to employees. As your workplace moves to a more data-driven mindset, the roles and expectations of employees will change as you implement the processes and the workflows. Rather than contributing, say, a certain amount of time to a project, employees will most likely focus on outcomes. And some employees will need more support in making this transition and understanding how they best contribute to the new context. So with your team thinking data, we can jump into some tools and data flows. What a data scientist does is use technology to find the best model to make predictions about similar future cases relevant to your current data. And for a data scientist, the beginning of this process is to choose a baseline. This is our common sense guard. Can your model do better at predicting outcomes than what is currently happening? Can it do better than a 50-50 chance? The common sense guard, the baseline, really asks us, can your model do better than a bunch of monkeys making pure guesses about the data? And the baseline tells us if we're above the line. Then yes, we're doing better than a bunch of monkeys guessing. And in data science, that's a really great start, honestly. Once we have a baseline, then we can start to get into our data and find the model that will best create predictions above the line. So in our case, we could use, for example, a Python library called Teapot. This runs your data against every possible model type it can think of: regression, classification, random tree forests, and then we'll tell you its top recommendations for the model type to use. Here we see a sample of Teapot running. It's using genetic engineering to choose a pipeline for one of the MNIST data sets. And in this instance, once Teapot's run 5 generations, it has an output that the best pipeline to be using is the K-neighbors classifier. It could also recommend 2 or 3 more models if we increased the population, which for us, in this case, the population would be about the model type. And from there, we have to decide which of these models is best. This is with an ROC graph. So the idea with an ROC graph is that it evolved from this old military radar in the 40s as an assessment. If we see something on the radar, should we send up a plane to destroy it? Remember, of course, we're in the 1940s in wartime. We've got limited planes, limited fuel, and we want to protect both our pilots and our people. So they developed this tool. In the ROC, a perfect score here with this star up at the top left means that we've hit every single enemy plane that could have caused harm. Down in this opposite corner, we sent up all of our planes every time something was on the radar, but it turned out none of these things was actually an enemy plane. We were up there looking at, I don't know, Canadian geese flocks, observational UFOs, who knows? We don't want that. It's a waste of our resources. Down here in the opposite corner, we decide to send up no planes ever, regardless of what's on radar. And up here in the top right, we're hitting a lot of the correct things, but also a bunch of other things at the same time. So coming back to our pretend data set, we can map our baseline across this plane, the ROC plane, and immediately discard models that give us results under the curve here. Because results here mean we're not hitting anything or we're hitting the wrong things. What we want is results up here. So how do we know which models fit here? We can run confusion matrices on the models and get output like this. And then we can take those and map them onto our ROC. So these numbers, which I've kind of made up, I haven't run a model on this, we can map them onto our ROC, and we can see qualitatively that model B has the best true positive results. So we'll just choose model B as the best one then. True positive here, of course, means we assume something was there and we successfully hit it. And that's pretty good, right? So our confusion matrix for this looks like this. We've got 39 true positives and 17 false negatives. It doesn't look too bad, right? So let me just ask you a question. With our play data set here, do you know what data set you're working with? What we're in fact working with is assessments of potential cancerous cells in patients. So this data is historical data that shows, after a doctor's appointment, the true positive, false negative, etc. rates of biopsy results and follow-ups. So when we say a false negative is only 17, what we mean is we received 17 concerned patients, and when we predictably assess them, they will be told they're fine and sent home with cancer and no treatment. Is that okay? And who decides if it's okay? Who is responsible for those patients' declining health and possible fatality? Who is responsible for that? And we do see quite a few of these cases in the news in the recent past. VW, Tesla car crash deaths. At the end of the day, is it on the dev who built it, the data scientists who set up the model, the business? We have no regulatory framework for this at this time. So if you look at this quick snippet from the online results, I think you can see where they're trying to place the blame. And in fact, rather than anyone in the business, they're trying to blame it on the user. In lieu of having strong guidelines outside of our organizations, we can develop and use key strategic management techniques inside of the organization to set us in a more resilient position. So with this play case we've been working with, the prediction of cancerous cells, what we've done so far is prepare the data. We didn't look at it too much, but we assume the data set we've been working with has already been prepared in such a way that key value pairs are great, data is all in a usable format, duplicates have been removed. We talked about modeling, from setting a baseline to creating a space with the ROC where we can evaluate performance to determining the model itself with teapots. And we looked a bit at evaluation of the model from a data sense with the confusion matrices and ROC. In data science, there's a model we use to explain this cycle, the CRISP-DM model. It's a business process framework for developing data science projects. And what we've done so far is highlighted here on the right at the bottom, data prep, modeling, and evaluation. And from a lab or data scientist perspective, we've done a pretty good job. We've used good data to create a well-fit model that has predictable outcomes. But coming back to our question, is it okay to send 17 people away from a doctor's office with cancer and tell them they're fine? Is that acceptable? And that's really a question that comes in on the business side. And my experience is that businesses are often equipped in the business understanding piece to pose a question, but lack some knowledge or experience in understanding the data. So how can we approach our question of how many patients is an acceptable number to send home with a serious illness? At the end of the day, the key here I want us to understand is that it's data scientists' job to use the tools and techniques on the data that we just explored. The meaning of those results, though, is not in the realm of the data scientist. So on the business side, we can create scenarios. Before we even get to data preparation, before we even get to the place where data scientists are running numbers and models, we need to set a landscape of scenarios. And the first part is the simplest in most cases. At the most basic, before anyone has opened data, what are the possible actions that could be taken once the data produces a result? In this case, it could be a patient is sent home, a patient is kept for further assessment, a patient has later follow-up. In another case, say with marketing, if we think about sending out a campaign flyer to entice current phone customers to stay with the company and renew their contract instead of going somewhere else, once we identify some people in our data set with contracts up for renewal, what are some possible actions we could take? We could do nothing. We could send them a flyer. We could funnel them into a marketing channel that isn't this one. And that's the first part. The second is describing as business owners what a false negative or true positive means. In the first case, a false negative, as we've learned, means someone's sent home and told they're fine when they're actually very ill. In the second case, with our phone marketing campaign, what does a false negative mean? Well, it means we've inaccurately predicted someone would leave their contract when they in fact stay. Which takes us to our third question in establishing context and meaning. How much does it cost to not send someone a flyer and they stay? Is there a more meaningful metric we might use here? Would it cost more, for example, to predict a customer will stay, send them a flyer, and find out they left anyway? This would be a false positive. And for this marketing case, I would say it costs more to have false positives. So with these action scenarios and costs in mind, we're in a much better position to assess our models. In the marketing case as business owners, we've decided false positives cost us much more than false negatives. So when we look at the confusion matrices, we can see which of these is most favorable for our business model. And here we can see it's model B. And if we look at our ROC and then map our budget against it, we might see that we can't afford B with the current budget. And we would select A then instead, which has more favorable conditions for the business in the context of the budget. So far we've talked about what big data is, some of the process of getting started with big data, and thinking strategically about use cases and impact. And one more important thing I want to chat a bit about is ownership of data. While we've established decision-making about impact and costs should fall at the level of business decision makers, we haven't taken much consideration for the data itself, which really, when you think about it, usually represents people. Again, coming back to our model here, for me, there's something that's fundamentally missing. I'm not sure if you see it or if you've noted it. But in this traditional diagram, the data itself is not actually connected to any particular process or outcome. Where does the data come from? How is it maintained? Can we edit it, add to it, throw it out? Part of me always wants to give them the benefit of the doubt with this diagram, but there are a lot of arrows and data just sits there right in the middle attached to absolutely nothing. This bothers me. And it's connected to this idea of maintaining the data and how we do that. So we can't cover everything in this talk, but I do want to look at a couple of core components of privacy by design. The idea that you should be architecting your app or model or process with consumer privacy needs at the core, always. Unlike in this talk, these components shouldn't be an add-on, but should instead be a driving principle of how the system is designed, hand in hand with the data collection, which connects it to, real world processes. The first of these two things is just that data has a life cycle. People are out there just trying to go to work and do their banking and adopt a cat, and you're just there processing their data forever. And as storage costs get smaller and smaller, this part of the process is often forgotten, but data should be deleted after a certain amount of time, and you should know what that time is before you even start collecting the data. People have the right to be forgotten. In some scenarios, 7 years of holding should do it for you. In hospital and other contexts, the life cycle may vary. You should rely on both local and international laws and standards to determine your life cycle. But this isn't just a business conversation. There's also a programmatic piece for implementation. How do we ensure the data is in fact deleted after 7 years? Does an update in a patient file reset that time? How do you ensure that it doesn't? Or should it reset the time? These decisions are at the business level, but then need to be communicated to the programmatic side so that they can implement the appropriate actions. And I guess the reason I'm talking about it here today is because it's often left to the devs and builders who may not understand what the rules are for this life cycle. So if you're a dev, bring this conversation to the business team. And if you're not, then as a business decision maker, please remember your dev's job is to implement. It's up to the business team to decide what the life cycle is and what the storage practices are. And we finally come to this ownership piece. At the simplest, ownership belongs to the decision-making group, which we've determined on the business side. However, this is a key point because as local regulations and GDPR in the EU come into effect, quite often there's a simple question that must be addressed in meeting the standards. And that email about privacy, about data lifecycle, about storage, accessing my data, who owns this, what are they going to do with it? And quite often what I'm seeing across businesses of all industries and sizes is either a generic email to the company admin or to the dev team. And I would offer that this is not the correct email address, given the ownership piece and where the decision-making falls. Ownership should not change as business titles change. Ownership should not change through maternity leaves, promotions, anything else. Ownership needs to be tended and cared for explicitly for all data across all time. Here in Norway, we have a health person elected for every business each year that has to teach us all how to use the fire extinguishers and find the fire exits twice a year. That person is formally appointed at a staff or board meeting through a vote, and the person then undertakes 2 weeks of training. Your ownership model for data may follow a similar model. It shouldn't just be Keith. Keith was the first one to start modeling the data. So, while data and analytics are revolutionizing our world and changing the way that we live and work, we have certainly come a long way from the Oracle and the Magic 8-Ball. We're doing a lot better. At the end of the day, it's the insights that are provided from the data that make them more powerful. While it is important to learn more about the data science processes that we explored a little bit today, it's even more important to be creating context for the data to live in. So how do we measure success of data? Well, the measure of success should be linked to how data moves key business priorities forward. And this can be at least partially measured by linking your KPIs to top-level business goals. At the end of the day, the power of big data is not how much you gather, but how you are able to use the information to drive core business goals. Once your company identifies the areas you want to tackle with data, what your core problem sets are, the first step is to focus on the real business problem and have that identified business problem lead the data project rather than the data. Always keep in mind that the data project cycle begins and restarts anew each cycle with the business question and understanding and the context within which the data will live. So, if your data scientists are either bringing you extraordinary results that make you super happy or results that you don't understand at all, I would say it's probably the business context that needs better refined to better represent the business problem in a way that can then be approached programmatically. You know, a lot of the time, what I've seen is a business leader poses a question, you know, how can we get the most renewals for this marketing campaign? And then they just take that and send it to data scientists who say, well, I guess we'll look at how long they've been there, or I guess we'll look at, I don't know, how much their contract is worth. But at the end of the day, the business side should be getting to a place where they can say very clearly, that they can articulate to the technical side, our question is, how do we make sure that everyone who's up for renewal on their contract takes the next contract? The three key things that we're looking at are time with the company, current value of all of their bills, and number of times they complained. Because that can be represented as a cost. And we're going to represent that cost using some math. So we need you to take the number of times they complain, apply some math to it, and apply this cost to that and multiply them. And that's how you're going to arrive to that number. That all should be on the business side. And then they can send it over to data science. And hopefully, my big hope for the world is that business leaders can have enough direction in understanding what those false positives and true negatives really mean. So of course, we want to be setting the scenario beforehand. And as folks in the technology space, we all have this drive to jump in and get to the tech already. Like, we just want to jump in and do some of those cool things with finding models and running numbers, so, you know, we can actually know that we're doing something. But as the keynote mentioned earlier today, it can be advantageous to go slow, to consider what it is that we're setting up here, because the impacts can be very massive. So just be sure that your business goals are driving the data project, and without the value and the context of scenarios, it can be easy to fall into that pile of big data failures. So I just want to invite you to go forth, set context, culture, and strategy, and make that data work for you. Just as we wrap up, again, as Sapphire mentioned, I'm one of the 2 Women Who Code fellows in the data science track. If you'd like to join us, you can join our Slack channel, which we can post a link to in a little bit. And you can find us at our next event on Tuesday, December 8th with our partner Wish, taking a look behind the scenes at what the data science leads at Wish are up to. It looks like it's going to be a really exciting event, and I'm really looking forward to it. And if you'd like to support more great talks like the Wish talk, like what's going on today, skills building workshops, leadership training for women in the Women Who Code community, you can always donate at womenwhocode.com/donate. Just $27 covers the cost of a Women Who Code membership for a year. Or if you're interested in partnering your company with Women Who Code, you can email partners@womenwhocode.com to learn more. I'm really glad that you joined me here today. As I said, you can always find me on Twitter at Naomi_Freeman, or you can email hello@naomifreeman.com. We are wrapping up a little bit early, but hopefully I can take some questions. I just want to make sure that, you know, we're on time and everyone can get a snack before the next session. I'll send it back to Sapphire.